Hi everybody and welcome to this video on simultaneous equations. During this video we will be having a look at the interpretation of simultaneous equations. So simultaneous equations are two or more equations solving for two or more variables. In most cases in this videos we have a look at two variables x and y, and we are solving then the point of intersection on a two-dimensional plane. So what we have over here is two equations. Y is equal to 3x plus 1. Let's call that equation 1. And what we also have is 2y minus 4. Let's call that equation 2. Now, if we have a look at equation 1 and if we think of our functions, we can see that this here is the equation of a straight line. And having a look at the equation 2, we can also see that it is an equation of a straight line. So what we're going to get by solving the solution simultaneously is the point of intersection of two straight lines. So let us find the solution for this, and you can use any of the methods discussed in the previous videos. I'm going to use the substitution method because y is already the subject in this equation. So since y is the subject, I'm going to substitute 1 into equation 2. So that means wherever I see a y in equation 2, I'm going to replace it with a 3x plus 1. So this here becomes 2 times 3x plus 1. So in the place of y, I put 3x plus 1 minus 4 is equal to 8x. Distributing, we get 6x plus 2 minus 4 is equal to 8x. And then we are solving for the equation, so minus 2 is equal to 2x, giving us that x is minus 1. So that is the first solution. Then what we're going to have to do is substitute it back in to get the second solution. So we're going to substitute x is equal to minus 1. And once again, you can substitute it into either equation 1 or equation 2. I'm going to choose equation 1 because it will make the math easier. So we have y is equal to 3, and now in the place of x, I'm going to put minus 1 plus 1. So this is y is equal to minus 3 plus 1, so y is equal to minus 2. So the solution or the point of intersection we expect is minus 1 and minus 2. If you are not sure or could not follow the steps in solving the simultaneous equation, please watch our previous methods, and I encourage you to try solving the same equation using the elimination method. So now let us have a look at the interpretation of the solution of minus 1 and minus 2. It is the point of intersection of two graphs. So what we have over here is the plot, the 3x, the y is equal to 3x plus 1, and the 2y minus 4 is equal to 8x. We find, since they're both straight lines, we find the x-intercept and the y-intercept. We find the x-intercept by making y equals 0, and we find the y-intercept by making x equals 0. If any of this seems unfamiliar, please watch our series on the straight line graph. Similarly, we find the x and y-intercept of the second equation and then plot both of them on the Cartesian plane. So over here in dark green, we have the first equation 1, and in light green, we have equation 2. So now let us have a look for this minus 1 and minus 2. So when x is equal to minus 1, and when y is equal to minus 2, we see we have a point of intersection. So that is what we found when we solved the simultaneous equation. It's where the two graphs intersect each other. I hope that you have found this video useful and interesting, and please watch the rest of the series.